Algebra 2. We are in Chapter 3, Lesson 6, the last lesson of the chapter. I would take good notes here because, it's our last lesson in the chapter, and for current listeners, we are on winter break after this, so we're going to need to take good notes so that we can remember it when we get back. Here we have our warm-ups. It's our little reminders. So let's evaluate this expression. I literally just plugged this into my calculator like this and got 16. This next one, you plug into your calculator. Please make sure you use the parentheses so that you can get your negative or your positive back. And we get an answer of -8. And really, I typed it in just like this. Oops, not just like that. Cool. All right, expand. Expand means I need to write it out fully and FOIL it. First, outer, inner, and last. Collect your inner like terms, and there you go. Solve the equation. So I need to set this equal to 0 and figure out what x equals. -45 minus 45. So I have x squared plus 5x minus 36 equals 0. So I need two numbers that multiply to -36 and add to 5. I'm thinking 4 and 9. A -4 times 9 is -36, and if I add those, I get 5. So go ahead and split that up. X plus 9, x minus 4 equals 0. Therefore, x equals -9, and x equals 4. Last one. A cone-shaped cup has a height of 7 centimeters and a radius of 2.5 centimeters. Use V equals 1/3 pi r squared h to find the volume of the cup. So my height is 7. My radius is 2.5. Go ahead and plug that in. 1/3 pi r squared times h. 1/3, just typing it out. You probably don't need to listen to me do this. Oops. I got a volume of 45.8 centimeters cubed. Don't forget your units. All right, into the new lesson. We're learning about solving radical equations today. So equations with radicals that have variables in their radicands, which is underneath, radicand is underneath, are called radical equations. An example of a radical equation is cubed root of 2x plus 7 equals 3. So there's just a few little key things to solve a radical equation. First of all, we isolate the radical on one side of the equation, if necessary. That just means, like what we see up here, let me get my right, there we go. I only have the radical on the left. There's no plus ones on the outside. There's no multiplications on the outside. It is just the radical. Okay, what we see right there is all by itself on the left side of the equal sign. Raise each side of the equation to the same power to eliminate the radical and obtain a linear, quadratic, or other polynomial equation. This is a cubed root, so we're going to raise both sides to the third power to eliminate that radical. And here we would have a linear equation because this is to the first power. Solve the polynomial equation using techniques you learned in previous chapters. Check your solution. So let's go ahead and try one. Hey, it's the same one. So I've got the radical isolated on the left. So So I need to raise this whole thing to the third power. That third power gets rid of that cubed root, so I just get 2x plus 7 on the left and 3 to the third power, which I believe is 27. Yep, on the right. Go ahead and solve it just like we learned to solve equations in past courses, really, not even in this course. X equals 10. And there we go. Now, with radicals, it's actually a really good idea to check your solution. And when I say the words check your solution, it doesn't mean just look over what you just did to make sure you got it. It means actually plugging in what your answer is to make sure that nothing happened. And with radicals, you can actually get answers that aren't correct, as crazy as it is. Cubed root of 27 is 3, therefore 3 equals 3. Oh, we already did that. All right, let's try again. That first step is isolate the radical on one side of the equation, so I need to isolate this. So I'm going to add 9 to both sides. I get 8 equals cubed root of x. Raise both sides to the third power. 8 to the third power is, oh goodness, hold on. 8 to the third power, 512. Two more. These are already isolated, so I'm going to square both sides. X plus 25 equals 16. I think that is negative 9. X equals negative 9. Okay, let's check this one, make sure, because I forgot to check the last one. I think I get a little arrogant in my math teacher abilities. I'm like, I don't need to check it. We're good. I did that right. And every once in a while, I get reminded that I'm not good. I do need to check my answers. So I have 4 equals 4. Okay, here's our first example of one where I have something multiplied on the outside. So I need to remove that first. So divide both sides by 2. I get cubed root of x minus 3 equals 2. Cube both those sides. I have x minus 3 equals 8. Add 3 to both sides. X equals 11. Let's go ahead and check that just to make sure. 11 minus 3. 11 minus 3 is 8. Cubed root of 8 is 2 times, 2 times 2 equals 4. All right, wind velocity. In a hurricane, the mean sustained wind velocity V in meters per second is given by that equation, where P is the air pressure in millibars at the center of the hurricane. Estimate the air pressure at the center of a hurricane when the mean sustained wind velocity is 54.5 meters per second. So I need to write that equation down. 6.3, 1013 minus P. Now they just told me that this is my wind velocity. So let's go ahead and try to solve for P. Okay, I need to get rid of that 6.3 because I can't square both sides with that out there. I can, but it's harder, and we don't like to make things hard, do we? 8.65, that's a point, equals square root. Okay, square both sides. I have 75.8. What would we do without calculators? They certainly make my life easier, don't they? Yes, Miss Carly, they do. 75.8 minus 1013, negative 938.2 equals negative P. I don't like that, so let's go ahead and multiply everything by negative 1. So P equals 938.2, approximately. I rounded a bit. what if my sustained wind velocity was 48.3 meters per second? Sorry, that equation was 6.3 10 13 minus p. So we're saying here I have 48.3. Divide both sides. 7.7. Square both sides. 58.8. Subtract 10 13. Negative 954.2 equals negative p. I don't like negatives. So p equals 954.2. Awesome. All right, rational exponents. When an equation contains a power with a rational exponent, you can solve the equation using a procedure similar to the one for solving radical equations. In this case, you first isolate the power and then raise each side of the equation to the reciprocal of the rational exponent. Just like a few minutes ago we had, I don't remember the problem, but this. We'll say 3. I would raise both sides to 3 to cancel out the radical. Well, this is the same as what we're doing. Okay, I would raise this to the reciprocal of 1/3 and get the exact same answer. All right, so let's look at this. What are the solutions to the equations? 4x to the 2/3 equals 36. So just like the previous examples, I still need to isolate this radical. Okay, that has not changed. That 4 is just multiplied with the x. It's not attached to the x. So we have to get rid of it 4. If we have to get rid of the 4, the 4 first. Stop laughing at me. It's not nice. Okay, so now I need to multiply both sides to the reciprocal. 3 halves, 3 halves. So the right side becomes 27 because I have a calculator that does that. And the left side, these two cancel each other out. So I'm good to go, right? Beautiful. Oh, hold on. I made a mistake. This is actually a square root of something cubed. Therefore, I have to include the positive and the negative. Sorry. Whenever we have an even root or an even radical, what that really is square root of 9 cubed. Okay, this means I need a plus or minus. All right, rules, I have to get rid of that. -1 first. I have x plus 2 to the 3/4 equals 8. I need to raise this to the 4/3. Okay, those cancel each other out. I have x plus 2 equals 8 to the 4/3, 16. Isn't it amazing how that mess just becomes a 16? Cool. Except I don't know how to add. That's hilarious. Don't judge me. It's almost Christmas or winter break. All right, let's try another one. I have to get rid of that 3 first. X, I'm still in red, sorry, equals 125. Let's change to blue. And keep it in blue. Those cancel each other out, so I've got x equals 25. Divide both sides by -2. This one's no different. x to the 3/4 equals 8. 4/3, 4/3, 16. These are pretty easy peasy. I hope you agree. I'm sorry, that could have been a really rude statement. If you're over there struggling up a storm and your teacher's sitting over here like, dang, this is easy. That's not a nice thing to say. If you need help, please. I do love math. I'd be happy to go over some with you one-on-one. Truth. Okay, I had a hard time typing that one into my calculator. Sorry. Lots of parentheses necessary. And it works out. Oh, I didn't have to do. Oh, yeah. We're good. All right, let's raise this to the 5th power. I have x equals 243. So many guided practices. I have 3 more. All right. 2/5, that's the reciprocal. 32 raised to the 2/5, that's 4. Subtract 3 from both sides. X equals 1. Okay, raise this to the 3/4. Now this is an even root. That 4 means that we could have a plus or minus. So this is a tricky one. We haven't done one like this yet. So I hope you're still following along and waiting for my bad jokes. I have x minus 5 equals 81 to the 3/4. I get plus or minus 27. So plus 27 or minus 27. Tricky. So now when I finish solving it, I can get x equals 32 or x equals negative 22. I have 2 answers and they're both valid. Minus 3, x plus 2 to the 2/3 equals 4. This is an odd root, so I'm good to, oh wait, no it isn't. Sorry, I need to raise this to the 3/2. That's an even root because that half. So I get x plus 2 equals 4 to the 3/2. 8 plus or minus 8. Subtract 2 from both sides. X equals 6. Subtract 2 from both sides. X equals negative 10. This is an OR. Awesome. Okay, this section right here is why we should be checking our work. Extraneous solutions. So raising each side of an equation to the same power may introduce extraneous solutions. When you use this procedure, you should always check each apparent solution with the original equation. Okay, extraneous just means extra. We can get solutions that aren't valid solutions. Okay, trust me, it happens. All right, it happens because when you square stuff, you get extra solutions. Here, I've got this isolated on the right and a binomial on the left. So when I square both sides, I have to FOIL the left. So I get x plus 1. Oh, for goodness sakes, that's messy. Hold on. The square on the right gets rid of the radical. Okay, over here now I have x squared plus outer is 1x, inner is 1x. I add those together to get 2x. If that step confused you, please show your work and it'll all be okay. Okay, solve it. Negative 5x minus 14 equals 0. All right, two things that multiply to negative 14 and add to negative 5. I think 7 times 2, if I get a negative 7 times 2. So I have x minus 7, x plus 2 equals 0, x equals 7, x equals negative 2. I need to grab this equation, my answers, and check my work. Okay, the original equation was x plus 1 equals 7x plus 15. So check, I've got 7 plus 1 equals, I'm plugging in 7 plus 15. 7 times 7 plus 15 gives me 64. 7 plus 1 does equal 8. We're good. I'm going to assume that this one is not good, but we will check our work anyway. Let's see, I have a negative 14 plus 15 is 1. So 7 plus 1 is 8. 8 is not equal to 1. Nope, that one doesn't work. Another type of problem, squaring twice. When an equation contains two radicals, you may need to square each side twice in order to eliminate both radicals. That's okay. Okay, we'll get it. This is probably our hardest problem, so I hope you haven't given up. Because I can't isolate the radicals, I'm going to have to square something twice. So I'll go slow. I need you to follow along and take some notes. So I'm squaring that. On the right side, it's easy peasy. And this time I'm not lying. Okay, gets rid of it. We're good to go. On the left, though, whew, doggy, this one's tough. I've got x plus 2 under the radical plus 1 and x plus 2 under the radical plus 1. Now we're foiling. So first times first, I've got x plus 2 outer. Sorry, first times first, when I have square root x plus 2 times square root x plus 2, that's like I'm squaring it. It's like I'm going like this. I should explain that if you don't remember. So my first times first is good. Now, outer gives me 1 times x plus 2. Inner gives me 1 times x plus 2. And last, we're good with last, right? Okay, collect like terms. I have an x plus 3 plus 2 times x plus 2 equals 3 minus x. Let's go ahead and go back to our original rules. Isolate the radical expression. Okay, so I'm going to move this over here. Nope. That gives me a negative 2x. And subtract 3. Whoa, that went away. Sweet. 2 times x plus 2. Get rid of the 2. I have square root x plus 2 equals negative x. Now I have to go again. I was just left with x plus 2 equals negative x. This is where it said sometimes I have to square again. So let's raise this to the second power and that to the second power. So I get x plus 2 equals x squared. Whew, still going. Now it's a polynomial, so I have to solve it just like the previous example, I guess. Okay, so I need two things that multiply to negative 2 and add to negative 1. So a negative 2 times 1 is negative 2, and if I add those, I get negative 1. So x minus 2, x plus 1, x equals 2, x equals negative 1. But oh no, wait, you're not done. We still need to check our solutions, because this is when we square both sides of things and we have to FOIL, we can get extra solutions. So let's check this in the original equation. You got to really search back to find the original equation though. X plus 2 plus 1, 3 minus x. So I'm going to plug a 2 in there. So I have 4. 3 minus 2 is 1. So I have 2 plus 1 equals 1. 3 does not equal 1. So that's a nope. I certainly hope this one works. I'm just kidding. One of them has to work, because if it doesn't, then we've done something wrong in the beginning. So negative 1 plus 2. Negative 1 plus 2 is 1. Square root of 1 is 1. 3 minus negative 1 is 4. 2 does in fact equal 2. We are good to go. Yay! Another way to do these, and you have to read through this. I didn't take a picture of my graphing calculator, but this is another way to go. Use a graph to solve the equation. Use a graphing calculator to graph the left side of the equation. Okay, this was our original equation, and the right side of the equation. So we would open up the y equals in our graphing calculator, type in one equation, and type in the other equation. Okay, then you can find the intersection of points of the two graphs by using the intersect feature. That is if you hit second calc, and number 5 is intersect. All right, I just took a picture of my calculator. Second calc, intersect. Okay, and your calculator will look like this. That's where you're going to have to select your curve. It'll say select y1, select y2, and then guess. And you'll have to put your little spider somewhere in the middle. Okay, I'd love it if you would practice this right now. And since you're in the room with me, say, yo, Miss Carly, I don't get it. All right, just like that. Yo, Miss Carly. Just kidding. All right, let's try a few. Solve the equation, check for extraneous solutions. They will remind you of this when it's a possibility. Here I see yucky fractions, and I'm going to have to FOIL the left side of that equation, and I really don't want to with that 1/2. So I'm going to multiply everything by 2 to get rid of it. Okay, that means I'm going to have a 2x, because I distribute, minus 1, yay, equals 2 times 1/4 x. Okay, now when I square both sides, I think it might be a little bit easier. So I write this one twice. I'm going to expand it. I know I have a 2 outside the radical here, and because there's no plus or minus there, it's actually not a big deal. So first times first, 4x squared, outer, inner, last. I'm going to square this. I have 4 times 1/4 x. Isn't that pretty how that goes away? On the right, these cancel, and I'm left with x. So 4x squared minus 4x plus 1. Subtract x from both sides. 4x squared minus 5x plus 1 equals 0. I need a new page. All right, there we go. So I need two things that multiply to 4 and add to negative 5. I think if I do negative 1 times negative 4, that works. So now I have to factor by grouping. Yeah, I don't want to do that. Let's get the 4's together. 4x squared minus 4x minus 1x plus 1 equals 0. So group. We've done this before. Take out a 4x. I'm left with just an x minus 1 Take out a 1, a negative 1. I'm left with x minus 1. So I have x minus 1 factored out and a 4x minus 1 left. Okay, this is from last chapter. If you're having a hard time remembering, please let me know. Okay, go ahead and solve. And now we need to check our answers. This is a hard problem, okay, lots of steps. So let's go ahead and check our answers. I had x equals 1 and x equals 1/4. I'm going to have to go back and check. I think so. Yes, so let's check it in our original equation. X minus 1/2 equals square root 1/4 x. So 1 minus 1/2, that is 1/2, equals square root of 1/4 times 1/4. Square root of 1/16, and that is the, oh no, square root of 1/16 is actually 1/4. 1/4 is not equal to 1/2. Let's try 1/4. Go ahead and substitute. Have I made a mistake? Oh, pause. Okay, I'm going to finish this side, checking the 1/4. I made a mistake on the left, but we'll go ahead and find it. I now see it. So this is a negative. 1/4 minus 1/2 is negative 1/4. And I know there's no way I'm going to get a negative over here because that's impossible. I can't take the square root of anything and get a negative. So I am certain that is a nope. Let's go ahead and trade to a red pen and find my mistakes over here. I hope you guys have found it. It's right there. I'm substituting a 1, not a 1/4. So on the right, I'm going to do this. 1/4 times 1, which is just 1/4, which is 1/2, which is a good. Sorry about that. All right, let's try another one. I think we have 3 more with this one. So let's go ahead and square both sides. Oh, I'm still in red, sorry. 10x plus 9. If I expand that, I'm going to get first, outer, inner, and last. 6x plus 9. So I'll subtract 9 from both sides, subtract 10x from both sides. I have 0 equals x squared minus 4x, and those cancel. Ooh, this is a good one. So let's go ahead and factor. That means that x can be equal to 0, which is this one, or x is equal to 4. Okay, I need a new page. I need to check for extraneous solutions. So I had x equals 0 or x equals 4. Let's go ahead and check them. I'm still in red pen, I'm sorry. We'll do 0 first. That's a 0. I get square root of 9 equals 3. That one works. And then we'll try 4. 10 times 4 plus 9 equals 4 plus 3. So I have, this is 40 plus 9 is 49. Square root of 49 is 7. And both are good. Let's change to a black pen before I move on. Okay, 2 more. All right, square both sides. 2x plus 5 equals x plus 7. I like positive x's. Oh, let's move the 5 to the left. Minus 5 minus 5. X equals 2. Well, if there was an extraneous solution here, I don't know what it would be because I only have one answer. Okay, so we're good. Oh man, our last one is the worst. I'm going to have to square twice. We can do it. It's our last example. Okay, on the left, I have x plus 6 equals the right, I'm good to go, x minus 2. All right, let's do this. First times first, I get rid of my square. Outer, I have minus 2 x plus 6. Inner, minus 2 x plus 6. And then last, plus 4. So collect like terms. I have x, and then a plus 6 and a plus 4, and then a minus 4 equals x minus 2. Okay, subtract x from both sides. Subtract 10 from both sides. And the right side is still negative 4x plus 6. And I need a new page. Add negative 4x plus 6 equals negative 12. Let's go ahead and get rid of that negative 4. So square root x plus 6 equals 3. Square both sides. X equals 3. Okay, again, I just have one solution, so I don't have to check for an extraneous one. Cool? Man, excellent work today. It's a long one. I'm super proud of you. My hair is actually in a ponytail today, but it still looks about that crazy, right? All right, I'm going to go through the daily homework quiz answers so you can check. There you go. Feel free to push pause. And again, feel free to push pause. And we are done. Again, good work.